Today's video will explain the UML class diagram for the standard template library Vector. Hello, I'm James Helfrich. The vector container in the standard template library has four attributes: the data, the number of elements, the number capacity, as well as the allocator. This video will explain those attributes as well as all the public methods involved in the vector. All right, we'll start with the class diagram. Now, the class is called Vector, so all we know is the class name is Vector. I'll leave my attributes and methods sections empty to begin with. Then all the containers have the same basic interfaces. They have a default constructor, they have a copy constructor, a move constructor, a destructor, and assignment operator. The vector also has an integer non-default constructor to make a vector of a given size, or a given size plus fill it with a t, as well as an initializer list constructor. Now, the vector must know the data type of the elements in the collection, and we represent that with a template variable. In this case, we'll call it t. Now, the client can determine the number of elements currently in the collection, and we do this with the size and the empty. The size will return the number of elements, and the empty will tell us whether the vector is empty or not. And we represent this with the num elements member variable. The client can also determine the current capacity of the collection. And notice the capacity is distinct from the size. In other words, I can have room for more elements even though those slots are not currently being used. And we keep track of this with the num capacity attribute. There is a collection of elements of type T, which can be directly managed to reserve, resize, and shrink to fit. So I'm going to call this attribute data, which is going to have 0 to many different T's in it. And this means I have to have a T, which is going to be a related class or data type, and it's related by association, but this association is very specific. It is composition. In other words, we create and destroy all instances of T with our vector, and there is a member variable of type T, which is the data, of course. And how many T's are there going to be? Well, many. We also have methods which will manipulate this collection. We call them reserve, resize, and shrink to fit. Reserve will increase the capacity without changing the number of elements. Resize will increase or decrease the number of elements, and shrink to fit will remove any excess capacity. Random access is afforded through the array index operator and the at method. Both of these return a t. Now there's two versions of each. There's the constant version, which returns a copy of t, and there's the read-write version, which allows the client to modify the data in the container. The vector allows the client to iterate through the collection, and we do this through the begin and end. Notice begin and end return an iterator, which means I need an iterator class. And this iterator class is going to be called the iterator, but it's a nested class. Therefore, I'm going to make it nested into vector. So the full name is vector : iterator. And the vector class is related to vector : iterator through association. In other words, begin and end are going to return an iterator object, but there is no iterator object as a member variable. And the iterator has one attribute, it's a pointer to a t. So we're going to call it p for pointer, and it's going to point to a t. And so now we're going to relate to that t by aggregation. Now what aggregation means is I'm going to have a member variable of type t, but I'm not going to create or destroy the t. In other words, if I create an iterator or if I destroy an iterator, that's not going to necessarily modify any elements in the collection. It's going to be 0 to 1, 0 in the case I'm not referring to any t, for an example, the end iterator, and 1 when I am referring to a specific element in the collection. Now, all iterators have the same public interfaces. We're going to have a constructor, a copy constructor, an assignment operator, a comparison operator, and so on. But the vector has a special non-default constructor, and this allows the vector to create a specific iterator referring to a specific element in the collection. There are functions specific to the vector that few other containers utilize. For an example, push back and push front allow me to increase the number of elements in the collection. Pop back and pop front allow me to remove the elements. Front and back allow me to directly access the front or last element. Insert and remove allow me to remove and insert elements in the middle of the collection. Now notice push back and pop back, front and back are all os of 1. Push front and pop front are os of n. In other words, I have to shift everything over. And insert and remove is also os of n because I got to shift everything to the right of the element being inserted or removed. The last part is the allocator. In other words, when I have a capacity that's greater than the size, then I want to make sure that extra capacity is not constructed or destructed. And the allocator gives me freedom to be able to manipulate that. So I'm going to have a composition class called A, and I'm going to have a member variable of type A, which is an allocator. And this allows me to, in one step, reserve memory, in a separate independent step called the constructor on that memory, in a third separate step called the destructor on that slot in memory, and finally be able to free that memory. Now, this is distinct from new and delete because new both reserves the memory and calls the constructor, and delete both calls the destructor and frees the memory. The allocator allows me to do these in separate steps. You can learn more about the class diagram of the vector chapter of the C++ data structures textbook.